Today we're going to take a look at normal distributions. So the first thing you want to do is we're going to take a look at these histograms. And they represent 500 healthy people whose temperature has been taken. So you can see histograms, that range of bins on the bottom. We have those temperature ranges with the percent of people. So this is the percent of people on the side who have that temperature. So 3 histograms represent that of approximately a normal, and 3 are non. So if you take a look at this, what makes something normal? So if you see this, it's kind of like we call this a bell curve. So a bell curve, where this one is a U, this one, it's not symmetric. And this one looks symmetric as well. So we could maybe even say that there's 4 of them, but to be normal, it should be perfectly symmetric. Now, what is a normal distribution? So certain things follow this normal distribution. Heights sometimes do scores on a test, so it's often called as the normal distribution or the bell curve. And there's a couple properties to it. It's symmetric about the mean. So the mean is that middle number. And now we talked about values of standard deviation last week. 68% of data falls within 1 standard deviation, 99% within 3, and 95% within 2 of the mean. So I think it's a lot easier to look at this with some problems here. So the weights of 1,000 children were recorded on their first birthdays. Their weights are normally distributed with a mean of 10.3 and a standard deviation of 1.6. So draw and label a graph. So I'm going to draw this curve, and in the middle of this curve, I'm going to put that we had a mean, so this is 10.3. And there's 3 standard deviations on each side. So I'm going to say 1, 2, 3, 1, 2, 3. And a standard deviation is 1.6. So all I'm going to do to this is add 1.6 to this. So 10.3 plus 1.6 is 11.9. Plus 1.6 would be 13.5. Plus 1.6, 13.5, 1.6, 15.1. And then to go within the other direction, we're going to subtract. So 10.3 minus 1.6. So this would be 8.7 minus 1.6, 7.1 minus 1.6, 5.5. Now here's the part that we're going to use that percentage of weights. So looking at this, what is the probability that the child weighs less than 10.3? Well, 10.3 is right here, right in the middle. So that's going to be 50%, because 50% on a bell curve is above and 50% is below. What is the probability that a child weighs between 8.7 and 10.3? So 8.7 and 11.9. Oops, sorry. 8.7 and 10.3. So that is 1 standard deviation away. And if we look back up here, 68% of data lies within 1, but that's 1 on either side. So if we're just looking at this chunk right here, that would be 34%, because on either side is 34, so this would be 34%. So it's kind of like saying 34% of our data points are here, 34% of our data points lie here. So of how many of 1,000 children would you expect to weigh between 11.1 and 11.9? 7.1 and 11.9. So I'm going to highlight this, change the color here. So we want between here and here. Well, if we divide this up within 1 standard deviation, we know that's 34%, but this other part is within 2 on that side. So if we go back up here and we look within 2 is 95%, So what's 95 divided by 2 is 47.5. So within 2 is 47.5. So 47.5% plus that 34%. So that would be, we got a 0.5, 81.5%. So we're going to do 0.815 times 1,000, and we have 815 children. And the last one, how many would you expect to weigh more than 8.7? Okay, well, more than 8.7 would be from here on up. So we know this chunk is 34, and on up is 50 from that half. So we're going to do 34 plus 50 is 84%. So 0.84 times 1,000 would be 840. So the second one that we're going to take a look at today, the monthly income of workers in Ghana is normally distributed. Suppose the monthly income is 1,250 and the standard deviation is 250. So if we're going to draw this, the mean goes in the center, and then we're going to do 3 standard deviations on either side, and we're going to go up 250. So this is 1,500, 1,750, and 2,000. So this would be 1,000, 750, and 500. So our question is, how many might earn more than 1,500? And again, there's a lot of ways, so we want from here on up. Well, if we know from here on up is 50%, and we know in between one standard deviation is 34%, so if we subtract those, 50 minus 34 is 16%, so 16% of workers, so 0.16 times 10,000, so we'd have 1,600 workers. How many earn less than 750? So here on down. So how are we going to figure out that percentage? Well, different ways we could go about doing it. So I'm going to highlight a different color here. So we know this is within 2 standard deviations. And we said that was 95% is within 2. So this is 95 divided by 2, so 47.5. But we know from here on down is 50. So we could do 50 minus 47.5. So 2.5%. So 0.025 times 10,000. So we have 250 workers. What percentage of the 10,000 workers earn between 500 and 1,750? So we are looking between 500 and 1,750. So again, look at standard deviations. From here to here is 3. From here to here is 2. So we know within 2 is 47.5. But what number is located within 3 is 99. But if we divide that by 2, so this would be 99 divided by 2, so we have 44.5%. So if we add those together, we have 80, 91, is that 92%? 92%. And then the last one, what percent earn less than 1,750? Well, I'm going to look at that again. Well, 1,750 is 2, and we want less, so we want all the way down. So that would be 30 plus 47.5, so that would be 97.5%.